G'day guys, we've got a question today on graph or curve sketching over particular domains. What we've got is we've got an exam question which I think is from last year's specialist maths exam, which is asking us to sketch the graph of f of x on the domain -6 to 8. So what I've done, guys, is I've come up with a bit of a checklist here with the things that we need to make sure that we do in order to give ourselves the most accurate representation of this particular function f of x on this domain as we possibly can. And just before we start, guys, I'd like to add to our checklist here. The one thing I'd like to add is if we've got a function over a particular domain is to make sure that we evaluate the function at the domain's endpoints. So I'm just going to write here for our own sort of reference endpoints. So to start with, guys, if we're going to refer directly to the checklist, we have to determine the function's x-intercepts on this domain. So the x-intercepts, guys, if we've got a rational function like this, where we've got f of x over g of x, the x-intercepts will be when the numerator is equal to 0, provided the denominator doesn't also equal to 0 at that point. Okay, so for our x-intercepts, guys, the numerator has to be equal to 0. So we know that for x take 3, x plus 1 has to equal to 0. Now we're going to use the null factor law to evaluate this. So basically we know that x take 3 would have to equal 0. So x will have to equal 3, or x is going to have to equal -1. So what we're going to do, let's just put them on our graph. For x equals 3, we've got an x-intercept that's here, and x equals -1. Got an x-intercept of just there. Okay, now onto our y-intercept. So like the checklist suggests, the y-intercept is simply the function evaluated at 0. So f of 0 is going to be equal to -4 times by 0 take 3 times by 0 plus 1 divided by 0 squared minus 2 times 0 minus 8. Cool. And for this, we're going to have at the top, we've got -4 times -3 is positive 12, times by 1 is simply just still positive 12. And then we have 0 take 8, which is equal to -8. 12 divided by -8 is equal to -1.5. So let's just draw that on the graph now, guys. -1, -1.5 is going to be approximately there. Okay, so the next thing that we have to check off are our vertical asymptotes. Now, if we've got a rational function like this, the vertical asymptotes are simply the values on the domain for which this function doesn't make sense. Now, put a little bit more simply, it's usually when the denominator is equal to 0. So in this case, if we have f of x over g of x, the vertical asymptotes are when g of x is equal to 0. Cool. So we've got g of x on the bottom of the graph here, which is x squared take 2x take 8. And that has to be equal to 0. Now for this, guys, I'm going to use the null factor law. So I'm going to have to factorize this. So to factorize this, we're going to have x minus 4, x plus 2 is equal to 0. And again, using the null factor law, I can say that x is going to have to equal 4, or x is going to have to equal -2. Cool, so let's go and draw those on the graph. Okay, so those are our two vertical asymptotes. Okay, now onto what I would consider the most tricky part of this entire problem, and that's the horizontal asymptotes. So basically what we have to do with the horizontal asymptotes is evaluate what this function does as x approaches positive infinity and negative infinity. So what we do is we take the limit as x approaches positive and negative infinity of the particular rational function. So we're going to do that now. So we're going to say that the horizontal asymptotes are equal to the limit as x approaches positive or negative infinity of this particular function. Cool, so this is what I'm going to be doing to evaluate the horizontal asymptote. Now from here, guys, what I'm going to do is I'm going to be able to take this -4 outside of the bracket, and I'm also going to multiply out those binomials just there to get my quadratic function similar to the one in the denominator. So by taking out the -4, it's going to be equal to -4 times the limit as x approaches positive and negative infinity of, so the numerator is going to be x squared, take 2x, take 3, and the denominator is still this function. So from here, guys, what I'm going to do is I'm going to try and change the numerator and the denominator. So rather than having terms that as x approaches positive and negative infinity, they tend towards infinity, I'm going to try and get terms that tend towards 0. Now, the way I'm going to do that is I'm going to divide both the numerator and the denominator by the highest power, which is x squared on both. So what that means is I'm going to divide the numerator by x squared as well as the denominator by x squared. Okay, so after dividing the numerator and the denominator by x squared, we can evaluate both of these fractional terms. So we have x squared divided by x squared in the numerator is going to be equal to 1. Then we're going to have minus. Now 2x divided by x squared is simply going to be 2 on x. And then we have minus 3 over x squared. Cool. Then we can move on to the denominator. So we have x squared divided by x squared again, which is simply 1, minus 2x on x squared is the same as the numerator. And then we have negative 8 on x squared. Cool, now let's just close up that bracket. Now from here, guys, we can actually evaluate the limits. So we're going to have negative 4 times the limit as x approaches positive or negative infinity of f of x is going to be equal to, well, when x approaches positive infinity, we've still got this 1 here, minus 2 divided by, when this goes to infinity, we're going to have 0. And when this one goes to infinity, 3 over infinity is going to tend towards also 0, divided by, and then we have 1 in the denominator, and similar to the top, minus 2 over infinity is going to be tending towards 0, 8 over infinity is also going to tend towards 0. So hopefully now you're starting to realize why I divided both the numerator and the denominator by x squared, because then I could make the 2 on x and the 3 on x squared tend towards 0 without affecting the actual function. So we have to remind ourselves as well that all of this inside the brackets has to be multiplied by negative 4. As well as noticing that we had to multiply what was in that bracket by negative 4, I hope you guys also realized that although I evaluated the limit as x tended towards positive infinity, because these terms are tending towards 0, it doesn't matter if I tend towards positive infinity or negative infinity, these 4 terms here will also tend towards 0 in the outcome. So then I can basically finish evaluating my limit, and I'll use a different color just so we can see what I'm doing. So we're going to say as x tends towards plus or minus infinity, f of x is going to tend towards, we've got 1 divided by 1 is 1 times negative 4 is negative 4. So we have our horizontal asymptote here, guys. Okay, guys, and to finish off all the information that we need is we're going to calculate the value of the function at the endpoints of the domain. So the first one we're going to do is the function at negative 6 and then the function at 8. And that just involves substituting negative 6 into this function up here, as well as finding the function at 8, which, would you believe, is also negative 4.5. So we can enter these two endpoints into our graph. So negative 4.5 is going to be approximately there, as well as approximately there. Okay, now it's time for us to bloody sketch the thing. Now this can be quite tricky, and it's also going to sort of make or break all of the work we've just done. If we've done all this work, we get all of this right, and then we just draw the most rank looking graph, then teachers could, or examiners could, take marks off just for the quality of the drawing. So just take your time on this last bit. Don't let all of this work you've done go to waste. So without further ado, let's see how I go with it. Okay, so I'm going to start on the lower part of my domain at x equals negative 6. And I know that because I calculated it before, the function at negative 6 is equal to negative 4.5. As x increases, my function is going to asymptote at x equals negative 2 to negative infinity. Moving on, I'm going to come from the upper point on my domain at x equals 8. We know that the function at this point is equal to negative 4.5 as well. As x gets smaller, the function is going to get more negative an asymptote where x equals 4 towards negative infinity. Now finally guys, here's the tricky part. Between x equals -2 and x equals 4, the function is going to come from positive infinity. We're going to have a root or an x-intercept at x equals -1. We're going to have a y-intercept at -1.5. We've got a turning point here. We're going to come back up through the other root or the other x-intercept at x equals 3 and then asymptote back to positive infinity. And so if we put some arrows on the values that get close to the asymptotes, so whoever's looking at our graph knows that these things will be tending towards positive and negative infinity at those points. We know that the graph is only from -6 to 8, but because the question doesn't include a domain, we can also put arrows on these parts of our graph to show that the graph will continue towards y equals -4 as x approaches positive and negative infinity. So there you have it guys. Here is the function f of x drawn or sketched on the domain -6 to 8. Now, moving forward, what I would imagine would be the most helpful under exam conditions is that you commit a checklist like this to memory. That will help to ensure that you're not missing any of the key points on the graph and that you get down all of the asymptotes, the intercepts, etc., etc., etc. So guys, again, these particular questions just require practice so you can develop a little bit of a intuition with where the function is going to go, which will help you get through these steps as quickly as possible. So guys, that's the end of the video. If it helped, please give it a thumbs up. Subscribe to my channel. I put out new videos as often as humanly possible. As well guys, if you had any problems with my method in sketching this particular graph, don't hesitate to leave them in the comments section below. Alternatively, if you've got any other mathematical related questions that you would like me to have a go at solving and making into a video, I'm always looking for new video ideas. So can you please leave them in the comments section below as well. But until next time guys, please subscribe to my channel. I'm still new and developing it, so every new subscriber helps. And until next time, just make sure you keep enjoying your maths.